Can you hear me?
Yes, teacher.
Can you see my face?
Yes.
Okay, today maybe I have to show you something, so I have to show my face.
Okay.
Why cannot see my face, Lee? So small only my face. I only see Yifen, very big. You
Teacher,
how?
you
Huh?
double tap your screen. You double tap your face
Okay,
there, the screen.
okay, can. So can you see my face or not?
Can, teacher?
Okay, right. So we are going to look at this problem. So before I demonstrate to you, I show you this problem first. Yeah, this problem. Okay, right. So this one is what we did the other day. Uh, no. This is the one, right? This is the one that you asked. Okay, so let me read to you this problem. A cone has a base. Are you looking at the problem, or the background is the problem, the geometer sketchpad, correct or not?
Can see. Yes, yes.
Yes, okay. So a cone has a base with radius 3 and a height of 4 centimeter. So it will be something like this, right? This is the cone, right? This is the cone. The height of the cone is from here until the bottom there, right? From here until the bottom. Now this one is called the slant height. This is not the height, this is the slant height. The actual height is like this one. Pass through the center of the circle and the center, the top of the cone, right? This is the height of the cone. Now the one here, the slanting one is 5 centimeter is the slant height. 4 centimeter is the actual height. This is the one that we always call height, right? This one is not the height. This is the slant height. Okay, right. So the radius of the cone is 3 cm. The height is 4 cm. When it is opened up, it forms a sector like this, PQ, OPQ, right? And given that OPQ is theta, find the value of theta. Okay, right. So how to show, right? Oh, new sharing. Now I want to go back to my face. I want to stop sharing. Stop sharing means you won't see this. You see my face. Okay, right. Right. So we come back to the problem. This one, right? Now this cone here, right? This cone here, the height is from here until the bottom here, right? The center point, the top point, the vertex until the bottom here. That is the height. Now, when you cut, you see here, there's a line here. Right? There's a line. Yeah, this one. There's a line here. So when I cut this cone, this way, okay. When I cut the cone along this line, I just use my scissors, right? Use the scissors and cut the cone, okay. So after cutting the cone, you become a sector like this. it will become a sector like this. Okay, yes, this is a sector. So how to get the sector become a cone? You take this, you fold up so that the two ends they join together, then you will become a cone. Okay, it will become a cone like this. Okay, right. Now there is a relationship between this sector. There's a relationship between this sector and the cone here. And the cone here. Now, so what is the relationship between the sector and the cone? Right? Okay, so earlier on, they say the height of the cone is the height of the cone here, the height of the cone from the vertex until the bottom is 4 cm, and the radius of the cone, right? The cone has a radius. The radius of the base is 3 cm. So 4 and 3, so it will make the slant height here 5 cm according to Pythagoras theorem. It should be 3, 4, 5. So the slant height is 5. Now, but you can see that the slant height is actually this line. Right? The slant height is actually this line. So when I cut up, okay, when I cut the corner along this line and open it up, so the slant height now becomes the radius, of the sector. Right? Then another thing is, now this cone has a base. This cone has a base, right? Okay, this cone has a base. Okay, the circumference of the base, when I cut it out and I open up, what do you think is the circumference of the base? What do you think is the circumference of this? This is the circumference of the base. The base of the cone, this is the circumference. When I cut it out, it becomes what? It becomes the arc of the sector. So there is a relationship between the cone and the sector, right? The slant height of the cone is the radius of the sector. The slant height here, right? The slant height of the cone is the radius of the sector. The circumference of the circle, the base circle, is the arc length. Is the arc length of this sector. Is the arc length of the sector. So anyone cannot understand the problem, you ask. Okay, I will show you again. I will show you this again. Okay, now can follow so far?
Yeah. For the slant height is radius, then for the circumference is what?
Okay, the slant height, this is the slant height of the cone. When you open up, right, this is the slant height of the cone, right? So when you cut open up, is the radius of the sector. Okay, right, this one you can follow. Then this one, the cone, the circumference of the cone, the circumference of the base of the cone. So I show you, right, the circumference. So this is the cone, right? This is a cone, and this is the circumference is here, right? The circumference is here. When you open up, this is the circumference, is the arc length of the sector. This is the sector, this is the arc length. So when the arc length is folded up, it becomes the circumference of the base of the cone. Any more questions? Sherwin, you just came in. Got question or not? No, then I will switch the screen. No need to look at my face anymore. We look at the computer.
Okay, teacher.
Okay, okay, then we switch to this one, right? We switch to this one. Okay. So now I'm afraid that you might forget. So I write here. Now the cone is here. The cone is here. So the three-dimensional cone, the radius of the circular base, this is the radius of the circular base, the red line, from the dot Q or P until the center of circle, this is the radius of the base. The radius of base is 3 cm. Height of the cone. Height of the cone is this line, 4 cm. Okay. Slant height of the cone. Slant height of the cone is this one, 5 cm. Right? Slant height of the cone is 5 cm. The curved surface area of the cone. Now, what do you mean by the curved surface area of the cone? So, can you see my face? I don't know. Can see my face or not? Here. Okay. So this is the curved surface area of the cone. The area surrounding the cone here, the top part, not the bottom. The bottom is called the area of base. Are you looking at my pic? Are you looking at at me, my screen, not the screen
Yes,
on the? Can you see my face at the corner there?
can.
Can. Okay. So this one is the curved surface area of the cone. Now this curved surface area of the cone, when you open up the cone, right? So the curved surface area is actually the area of sector. When you fold it up, this one becomes the cone, right? So the curved surface area of the cone, when you open up, is actually the area of the sector. So here, right, the slant height of the cone, the curved surface area of the cone. So do you know what I am talking about in this picture here, the cone here? Do you know what I'm talking about? All the various dimensions of the cone. Okay or not? Anyone
Okay,
don't understand the number or the name given to the lines? Li Ying said okay. Then other girls, okay or not? How many girls we have today? I don't know. Let me check here. 8, 7, 7. So the others can? Okay. So if no problem, then we open up the cone and it becomes a sector. So this is the sector, right? So over here, I tell you two things lah. Area of sector, that means this white color part. This white color part, the area of sector, is the curved surface area of the cone. It actually comes from the curved surface area of the cone. The radius of this sector, is this one. The radius of this sector. The radius of sector is actually the slant height of the cone. Okay, now the slant height of the cone. Okay. So far, any question or not? Can follow?
can.
Okay, can. So now we go on how to solve the problem. Okay, this is the first part. Okay, consider the cone. So we look at the cone. The vertical height is 4. Radius of base is 3. Right? Until here, the radius of base is 3. So the circumference of the base, the green line, the circumference of the base is the green line. The green line. So the circumference of the base is 2 pi r1. Now why should I put r1 there? Because there are two r's. The first r is the radius of the base of the cone. The second r is actually the radius of the sector. When you cut open, it's the radius of sector. So here, the circumference of the base of the cone, the radius of the base of a cone, I use r1. That means r1 is referring to 3. It's referring to 3, right? It's referring to this. So, so r1, 2 pi r1. 2 pi is 2 pi lah. R1 is 3. So altogether, the circumference of the cone, or the base of the cone, is 6 pi. 2 times 3 is 6 pi. I leave the answer in terms of pi, 6 pi. Then using Pythagoras theorem, I find this side, the slant height of the cone. So 3 square plus 4 square is actually 5 square, right? So the slant height of the cone is 5 cm. Okay, so now the first thing is I try to find out everything about this cone. I try to find out everything about this cone. So are you familiar with the cone now, with the various dimension and the names of the different parts and different lines on the cone? So far, okay?
Yes, okay.
Ah, okay or not? So this is the first part. I want to explain to you about the cone. So if you have no question, then we go on to the sector, right? We go on to the sector. So consider the major sector OPQ. So major sector OPQ is referring to this part, not this side. It's referring to this part. So the major arc length is referring to this green line here. So the major arc length is of OPQ. We want to look at the major arc OPQ, and the major arc length is this one. Now what is the radius of OP? R2. Radius of sector OP is R2. R2 we have found out earlier, the R2 is 5 cm. R2 is 5 cm. So let's say I want to link up the arc length here and the radius here and also the angle here. These three quantities, right? The radius, the arc length, and the angle. So now the arc length comes from the circumference. So the arc length, the green color, come from the circumference. So PQ, the major arc length, which is the circumference of the cone, is 6 pi. Okay, but we also know that the arc length is S equals to R theta. So R theta, which is also equal to R theta. So R theta is 6 pi. R is 5. So theta is 6 pi over 5. So this is the angle theta. Okay, find the value of theta. They didn't ask us to find the value in terms of degree or in terms of radian. So I just leave the answer in terms of radian, which is more accurate. So far, okay or not? I relate the circumference of the cone with the arc length of the sector. So equal, make the two of them equal. So once the two of them equal, you can find the theta. So far, okay or not? Okay.
Okay.
So, okay or not? Okay or not? Who are they? 7 person. 7 person. So, who are they? Let me see. Okay. Ethan. Okay. Ethan, okay or not? Can follow or not? Okay. Ethan say okay. Ethan say okay. Right. So now I continue to find the area, right? Area of the major sector. That means this part. I want to find the area of this part. So area of this part, I use the formula half r squared theta. Now the r comes from the big circle, right, from this sector, so I use 5. The angle I have found earlier, this angle theta, is actually this angle here, 6 pi over 5. So half r squared theta is half 5 square, which is the radius of the sector, and theta is 6 pi over 5. 6 pi over 5 found here. So altogether is 15 pi. Altogether is 15 pi. So
Teacher, the pi don't need to sub with the 3.142.
it's more accurate. No need to use 3.14159, right? You can leave in
Okay.
the answer in terms of pi, right? If you change it to 3.14159 into decimal places, then it may not be so accurate, right? So here they didn't tell us whether they want in terms of pi or not. Leave in terms of pi because it's more accurate. Okay, so we move on to back to this one. The last lesson, I didn't do this application of circular measure, and this application of circular measure is, oh yeah, not finished yet. Okay, any question? Li Yin, other girls, where is the cannot see where is it? Okay, must be this one. No, not this. This one. Ah, yes, this one. So this question, any more want to ask? Huh? Xing Yi, any question? Cannot understand, want to ask? Hmm. Xing Yi, your friend need help or not? Any of your friend cannot follow the lesson? Huh? Any of your friend cannot follow the lesson, want to need help, then you can ask them to join us. Okay, right. So this one, okay, no problem. So we come back to the this one. Yes, the application of the circular measure. So this question is from the textbook. I'm going to read it out. A cylindrical cake has a radius of 11 centimeter. So this part here, the cake, the top part of the cake here, 11 centimeter, and 8 centimeter the height. So the height of the cake here, 8 centimeter, right? So the diagram shows a uniform cross section of a slice of cake in the form of a sector POQ being cut from the cylindrical cake with center O and radius 11 centimeter. Given that angle POQ equals to 40 degrees. So I have drawn out the piece of cake here, right? Now all this we follow the numbers given in the question. The angle is 40, the radius is 11. Of course, there is a vertical height here, which is 8 cm, right? Which is 8 cm, right? But I didn't show the vertical height. Vertical height here 8 cm, right? Something like that. Okay, right. So this part don't want to show, right? This part don't want to show. So you just look at the top part of the cake. Calculate the perimeter of the sector OPQ. So we just want the top part, the perimeter of the top part. Doesn't include the bottom here, right? So perimeter of the sector is OP, OQ plus the arc length PQ. OP, OQ plus arc length PQ. So OP is R, OQ is also R. Then the arc length is R theta, S equals to R theta. So substitute in R is 11, 11, 11. Now this angle 40 degrees, you have to convert into radian, right? They are given to you in the form of degree, 40. But you have to convert to radian. How to convert to radian? Multiply by pi over 180. So 22 plus this number, which is 29.679. Is the answer. Okay, right. Next, they want us to find the area of sector OPQ. So this sector here, this area here, OPQ. They want us to find the area, this part here, area OPQ. So we use the formula half r square theta, right? So want to find area of sector half r square theta. Okay, this part, area of sector, this part. Half is half, radius is 11, so 11 square. Then the angle is 40 times pi over 180. So it's 121 pi over 9. Or if you want to use the calculator, 42.237. So where is this girl? Li Yin. Okay. So you can either leave the answer in terms of pi or in terms of decimal place. Now, why just now I prefer to leave in terms of pi, and now I want to calculate out the answer in decimal place? There's only one reason, because this number here, 121 pi over 9, very big, many numbers there, right? There are many numbers, 121, then divide by 9 and 5. So I feel that maybe I need to change to decimal. Now, whereas in the previous case here, just now, the last one, the previous case, where is it? Here. Now, here, very nice, 15 pi. If I multiply out into a decimal, then not nice already. The number is not nice. The 15 pi is very nice. Here, 6 pi over 5. They are very nice fractions or whole numbers. So I want to keep them in this form. Now, whereas this here, 121 pi over 9, not very nice. So I change it to a decimal number. So you know what I want, why I do this or not, Li Ying?
Okay, understand,
Okay,
teacher.
so some funny one I change. Not funny one, very nice one, don't change. So now they want the volume of the cake cut out in centimeter. Now volume you have learned, I don't know lower form how you learn it. Now volume of any solid which is uniform, you use the cross-sectional area, multiply with the height, then you will get the volume of the object. So I'm going to do that. So if I want to find the volume, I use the area of this one, the uniform area of the sector, multiply with the height of the cake. Okay, so the volume of the cake is the height multiplied by the cross-sectional area. Now this part is what I meant by the cross-sectional area. So 8 multiplied by 42.24 is 392 cubic centimeter. Okay or not? Just use the cross-section, multiply. Most of the uniform solid, you can do it that way. If it is a cone or if it's a pyramid, then you use another number, a fraction in front, 1/3 height multiplied by the cross-sectional area. There's a 1/3 in front. If it is pointed like a cone or pointed like a pyramid, then you use 1/3. If not, then just use the height multiplied by the cross-sectional area. So this is the answer, right? Last one. If the mass of the cake is 150 gram, calculate the mass of the whole cake in grams. Okay, right. Now, this 40 degrees is 150 grams. So we want the whole cake. The whole cake is how many degrees? 360 degrees. So we use ratio. Just like your chemistry, when you want to calculate the molecular weight and the weight in grams, something like this. You have to relate it. Right. So now the mass of the cake here, right, the question mark, divide by 150, mass of cake divided by 150, is actually the ratio of the angle, 360 divided by 40. 360 divided by 40. Don't try to imagine, make it the problem very difficult, or you're going to do a lot of things to find the volume of the cake. No need to find the volume of the whole cake, right? You just use the ratio of the angle. The bottom part is uniform, so you don't have to worry. So moving the 150 over, we have 1,350 grams. This answer is correct. It's given
Teacher,
yes.
if we take 360 degree divided by 40, then we get 9. Then we take the 150 times with 9, can?
Can. As long as you know what you are doing, it's okay one. Right? Any more? Any more questions? No, then we move on to the next problem. Okay, next problem. This is very, this is difficult, no? This problem is really a problem. This is really a problem. Ah, okay, right. We move this away first. Right. Now, the question is like this, right? The question is like this. The diagram on the right, actually I cut it and put it on the at the bottom already, right? The diagram on the right is a semicircle. Now the semicircle is here, from the straight line here, then move along the circle here. This is the semicircle. AOB. This is the semicircle AOB. So AOB is a semicircle with center D. This is the center of the semicircle. Right? Then there's another circle AEB. AEB, this part. This is actually the arc of another circle, not the same circle. Now this other circle, the center is at C. The center is at C here. So there are two circles overlap on top of one another. The first one is a semicircle. The second one is a sector, minor sector on top of it. So they overlap on top of one another. Now, the arc of a circle with center C77. So this is the coordinate. And the equation of AB is 8 over 6 plus, x over 6 plus y over 8 equals to 1. Now this equation is given to you in intercept form. Now have you learned intercept form in your Form 4 coordinate geometry? Have you learned intercept form? Don't know, never mind. Right, now if it is given to you x over 6, y over 8 equals to 1. It means that there is a point here. This point, the y intercept is 8. So that means the point A is 0, 8. They give you in this form, y over 8. That means the y-intercept is 8. Now, y-intercept is 8. The coordinate is not 8. The coordinate of A is 0, 8. Okay. Oh, also from the intercept form, x over 6. X over 6, it means the x-intercept is 6. But the coordinate of this point is 6, 0. 6, 0. So you must know the number and the actual coordinate. There are two different forms. If they ask for intercept, it's a number. But if they ask for the point, it's a coordinate. It's a pair of numbers. Okay, right. Okay, so now consider right angle triangle AOB. AOB. This one. Now this is a right angle triangle. Now you have learned in your Form 3 chapter 6 that the diameter subtend a right angle at the circumference. Can you remember this? Mathematics. Diameter, this diameter AB, subtend a right angle O at the circumference of the circle. Because it's a diameter, the angle must be 90 degrees. Okay, right. So this point O must be on the circumference, right? Okay, now consider this right angle triangle AOB, right? The area of this triangle AOB, I want to find this triangle. This triangle AOB is a right angle triangle bounded by the x-axis, y-axis, and the equation of the line. So that triangle, I want to find the area. Okay, right. First of all, I know this is 8, this is 6, this is 8. So do I know what is the length AB? Because this is a right angle triangle. So using Pythagoras theorem, I know AB is 10 units. If I know AB is 10 units, it means that the diameter of the circle is 10 units. The radius is 5. Okay or not so far? You say
Teacher,
okay, then I continue. Yeah? Okay,
just
right.
now for the x over 6 means the coordinate for x is 6.
Yes.
So for another coordinate is 0.
Wait, I turn on the volume louder. I cannot hear. Yes. Can you ask the question again?
For just now, the x over 6
Yes,
means the x coordinate is 6.
the x coordinate of the point on the x-axis. There's another point there on the y-axis. Y-axis one, no. Okay, now y-axis one is the number below the y. The x-axis is the number below the x. Correct.
Okay, okay.
Okay, okay, right. So now we know that this is 6, 8, then the other one must be 10. So when this is 10, when this hypotenuse is 10, it means that the diameter of the circle is also 10. Now, never mind about that. Then I try to find uh, the area of triangle. Triangle. This is what? 7, 7. This is area of triangle A ABC. This is area of triangle ABC. Right? This is area of triangle ABC. So let me put down here area of triangle. Area of triangle. Area of triangle ABC. This is the area of triangle ABC. Right? Wait, okay, pull this further apart. Okay, wait, pull this out, then this one. Yes, so area of triangle ABC is half, then 77086077. Have you learned this formula in Form 4 coordinate geometry? Yes or
Yes,
no?
got.
Yes. So we know the coordinates of the 3 points. The 3 points, they are 0, 0, 8, 6, 0, and 7, 7. So if you want to find the area of this enclosed within this, the interior of these 3 points, then you arrange the coordinates vertically, then you find the modulus, right? So finally you multiply it out and you will get 25 units. Okay, next part. Next part is find the angle ACB in degrees. ACB. That means is the angle of this sector. The angle of this sector. So how to find? So consider the right angle triangle ADC. 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 Now why is I call this ADC a right angle triangle? Because ABC comes from a circle. They are isosceles triangle. So I split them up. I bisect the angle C into two parts. So since it's an isosceles triangle, when you cut them with the line AC, they are divided into two equal parts. So when they become two equal parts, this ADC is actually a right angle triangle. From an isosceles triangle, I bisect into two right angle triangle. So now AC is square root of 50. Or I use the distance between 2 points, the formula, right? A is 0, 8, C is 7, 7. So 0 minus 7 square, 8 minus 7 square, and that will be this line, AC, or the radius of the sector. D is the midpoint of AB. This is D, is the midpoint of AB. Why? Because D is the center of the circle. If D is the center of circle, then the two parts must be the same. AD and DB must be the same. So if the whole thing is 10, the radius must be 5. So the radius is 5. So I know this 5, I know this square root of 50, these two. Right? This AD is 5, AC is square root of 50. So which formula I want to use? I want to use the trigonometric formula, the trigonometric ratio. sine, right? So 5 over square root of 50, 5 over square root of 50, right, is like this. You have learned cert in form 4. So this 50 you can change to 5 root 2. The 5 and 5 cancel, and ACD is 1 over root 2. Now if you remember, 1 over root 2 means what? 1 over root 2 is 45 degrees. You don't have to look at the table. Oh, no, sorry, you don't have to use the calculator.